All right, here we are reviewing some curve sketching stuff. So remember, most of this is review, and I know that that doesn't make it any easier, but it starts to click. So the first thing we're going to do on this one, it asks for the end behavior asymptote. So this is the one new thing that we learned is an end behavior asymptote. Remember, that happens when the degree of the top is greater than the degree of the bottom. And that means there's no horizontal asymptote. It's not a horizontal line. The end behavior approaches this slant asymptote. But we find that by using long division. So we do long division to find our end behavior asymptote. And remember, I much prefer long division inside of the box. It just is cleaner and it's more intuitive. But if you want to do it with, the traditional algorithm, that's fine too. So we're going to divide x cubed minus 9x by 3x squared minus 6x minus 9. Now remember, what that means is that this factor times this factor equals our answer, right? And if you think about division, this is the answer, this is a factor, and we're looking for the other factor, right? That's what division means. Okay, so we're going to start and we're going to say, what do I need? I need x cubed, right? That's what I need. Well, what times 3x squared equals x cubed? This is a little tricky. 1/3 x times 3x squared would give us x cubed, right? Because 1/3 times 3 is 1. So 1/3 x. All right. Now, if that's 1/3 x, remember, anytime we multiply polynomials, they multiply, each term multiplies by each term. So we've got to multiply that 1/3 by negative 6x and by negative 9. So 1/3 times negative 6 is negative 2x squared. And by negative 9 is negative 3x. Okay. Now, the other thing we know is that when we multiply these two factors together, the answer gets in here, but it adds up in here, right? So we have like x cubed, and then some things with x squared, they all add up together to equal our 2x squared that we have here, or 0x squared that we have in here. So when we do this, when we multiply this times this factor, the insides add up to be what we see. So up here we see 0x squared, and we have negative 2x squared, which means we need a positive 2x squared. We need positive 2x squared so that when we add those together, they're going to equal 0. Now, what in the world could I multiply 3x squared by to get 2x squared? Again, it's a little tricky, but think about it. We could multiply by 2/3, couldn't we? Because 2/3, the 3's would cancel out, and I get 2x squared. Okay, so now I just multiply down. 2/3, that would be negative 2 times 2, which is negative 4x. And then that would be negative 3 times 2, which is negative 6. Okay, so far, I'll go ahead and highlight this. I'll show you. My x cubes cancel out, or not cancel out, I don't want to say that. They add together to be what I need them to be, right? X cubes work, x squareds work. Now we're working on x's, right? So I have negative 3x, negative 4x, I need negative 9, so I'm going to get negative 2x, that's going to give me negative 9. And then, is there anything that multiplies by 3x squared to get negative 2? No, there's not. So this is just our remainder column. Okay, this is just our remainder because, see, we got our x, we got our constant, and once we hit the constant, we're done dividing, right? This is like in long division. This is like when you hit that decimal point. We're done, and the rest of it after is a remainder. So everything is a remainder. So now our x's add up properly, right? And so now all we need is our constants to add up, and so this is going to have to be 6, so that our constants add up to 0. So the answer of x cubed minus 9x divided by 3x squared minus 6x minus 9 is 1/3. Oh, I forgot to switch out of the highlighter. That would not be very good to read. 1/3 x plus 2/3 minus 2x plus 6 over 3x squared minus 6x minus 9, because that's our remainder. Now remember that our horizontal or end behavior asymptote is this piece right here. It's everything except for the remainder, okay? This is our end behavior asymptote. So when I say, what is your end behavior asymptote, you would write y equals 1/3 x plus 2/3. And then you're done. That's the end behavior asymptote. Okay, so now we're going to find the holes and the vertical asymptotes. So for this one, you're going to want to factor everything. So this is going to factor into, I have to just look because I don't have it on the screen right here. So x cubed minus 9x. Okay, so that's going to factor into x times x squared minus 9 over 3 times x squared minus 6x, not 6x minus 2x minus 3. Now, a lot of you tried slide and divide bottoms up on that bottom one to factor it, and you forgot that slide and divide bottoms up fails when you have a greatest common factor. You just have to remember that you took that greatest common factor out. So you, if you notice, we take the greatest common factor out. We don't even need slide and divide bottoms up anymore. So don't just arbitrarily like apply slide and divide bottoms up just because you see a number in front. Check for a greatest common factor first, because if you don't, you're going to end up with factors that don't actually work. So we have x times x minus 3, x plus 3, 3 times x minus 3, and x plus 1. All right. So now we have things that can cancel out, right? Well, actually, let's do this first. What are our discontinuities? What makes our denominator equal to 0? Well, if I put a 3 in here or if I put a -1, I would have a discontinuity, right? 3 and -1. Those are our two discontinuities. And we know all discontinuities are either holes or asymptotes. So then I look to see that these two cancel out. So I realize that this is a hole. This one, x plus 1, does not cancel out, so that's a vertical asymptote. Then it asks us to label each asymptote as even or odd. So to tell if an asymptote is even or odd, I look at the multiplicity of the factor that created the asymptote. Okay? So what factor created the asymptote? -1. It's this factor right here, right? This factor is what caused me to have an asymptote at -1. So because this factor has a degree of 1, which is an odd number, my vertical asymptote is also odd. And then remember to find the rest of the hole. I know that there's a hole at 3 something, but I don't know what that something is. So to find that something, I go back to my original equation, my simplified equation, and everywhere that there was an x, I just plug in a 3. So I have 6 on top, and I have 12 on bottom. Oh, I erased another 3. I'm like, I know that's not right. Okay, 3 times 6, which is 18. So my hole is at 18 over 12. And 18 over 12 simplifies to 3 over 2. So I have a hole at 3 3/2. Okay, so what we're doing is we're stepping into being able to graph this. So now we found a slant asymptote. We found our holes. We found our vertical asymptotes. Then we find the intercepts. And the last one is actually the easiest part because you've already found all of the pieces and parts. And it feels really hard, but it's not. So let's find the x-intercepts and y-intercepts. So y-intercept is the easiest of all because you just set x equal to 0. Oh, and I do have it written right here. So we can look. If I put 0 in here, I have 0 times who cares because I just multiplied by 0. And who cares down here, right? I have 0. Does that make sense? If I put in 0, I get 0 times -9 over 3 times -3. Doesn't really matter because I have a 0 on top. So my y-intercept is 0, 0. okay? Because when x equals 0, y equals 0. Now we're going to look for our x-intercepts. Now remember, our x-intercepts are where y equals 0, so we set our function equal to 0. And we always want to use our simplified function here, because if we use the other function, it'll often give us a hole that doesn't actually exist as an as an intercept. So just always use your simplified function. Okay? So when is this function equal to 0? Well, it's equal to 0 when the numerator is equal to 0, because the denominator can never equal 0. And when is the numerator equal to 0? Either when x equals 0 or when x plus 3 equals 0. That's the zero product property. So we know we have x-intercepts at x equals 0 and at x equals negative 3. X-intercepts x equals 0, x equals negative 3. Okay, so now we found all of our pieces and parts, and we can go ahead and graph. So the first thing that it doesn't matter which order you graph these in. Let's start with our vertical asymptote. I always like that just because it's like really, I don't know, it's easy, right? Okay, and then we have a slant asymptote at, so it's 1/3 x plus 2/3, which means it starts at 2/3, and it goes up 1 over 3, up 1 over 3. Okay, so I have this slant asymptote. I really should learn to be better at making straight lines on this. Okay, so there's our slant asymptote, and we know that our function is going to have x-intercepts. Let's say I wrote these down, 0 and negative 3. So it goes through 0, 0, and it goes through negative 3, 1, 2, 3. Okay, and we know that it doesn't cross the x-axis after that. Those are the only two places it crosses the x-axis. It crosses the y-axis at 0, which we already wrote, and then it has a hole at 3 3/2. So 1, 2, 3, 3/2, which is just below our asymptote there. But remember, we can cross or touch slant or horizontal asymptotes. So don't freak out if it crosses or touches a horizontal asymptote. Okay, so then I think about, I know it has to go through this point. Okay, can it go toward the asymptote this way? No, because it can't go that way, right? It's going to go this way. It's going to approach the asymptote this way, okay? And then right here, we're going to approach the asymptote this way. So we're going to connect these dots, and we're going to bring it down, and there's that half, okay? Because what I know is, since this domain is everything except for negative 1, either the function has to be in this quadrant, or it has to be in this quadrant. Like, it has to be in those parts, right? I can't have a piece of my function up here and a piece of my function down here, because then it wouldn't be a function, right? If you had something that, like, up here, well, that's no longer a function. So I know it either has to be down here or it has to be up here. And since these holes and everything are down here, I know it's there. And same thing here. The rest of it either has to be here or it has to be here. Well, it can't be down here because it has to go through that point. So I know it goes through this point and approaches that asymptote. The other thing that I know is that my vertical asymptote is odd. And since my vertical asymptote is odd, and this goes down, this one has to approach up, right? They can't both approach the asymptote from the same direction. That would be an even asymptote. So there we go. That one is all graphed. I'll try to make another video. Looks like I'm out of time for the class period, but I'll try to make another video later, so please watch for that, and that'll do the other one, which is slightly more complicated and kind of not.